Hi everyone, uh, and I welcome you all to my YouTube channel for the design part, and this would be a very important thing, right? And this is like no before we talk about a lot of design patterns, how to implement, where to implement, and all right. We must be knowing what is design pattern, what it is not, right? What are the different kinds of design patterns we have? Then we will also talk about what are the things that it gives to you, when to use design pattern, when not to use design pattern, how to decide what kind of design pattern we should be using. So these are some basic things that we must be knowing, that we must be going through, we must be discussing, and we must be thinking through, right? Before we go ahead and start implementing any design pattern or start picking up any design pattern and then start implementing those design patterns in our application or in our project, right? So let's start our session with the discussion of what is design pattern, one of the most exciting and most important question for any interview. For anybody who is having anywhere more than 5 years of experience, but anywhere, even the person who is having less number of years of experience, it is good that they also know about all these things so that they can start implementing this, can start thinking through it, right? And then it will definitely help them, those people also, to in their interviews and all. And if you are able to answer these kind of questions, even if you are 2 years experience or 3 year experience, and mostly nobody will ask, but if somebody by chance asks you, and if you are able to answer these things, it will be a kind of very good positive note for your interview, and it will go in a very good positive way for you. So just to try to understand now today what is design pattern, right? So let's start our session with what is design pattern. So what is design pattern? So basically what happens, uh, see, I have been working in IT industry for more than 15 years, and I have worked for many number of applications, many number of clients. And what I have seen is there are, so let's say I have worked for various projects in various domains and all, right, and different kind of applications. And I have seen so many different kind of use case, so many of business case scenarios and all those stuff, business requirements. But does it mean that only I have worked on those kind of problems? Let's say I have worked on 10, 15, or 20 applications. But do we really have only 10, 15, or 20 applications in the world? There are lakhs and lakhs and lakhs of softwares, lakhs and lakhs of applications, and a lot of people work, right? But then, well, let's say, if you see, take an example of retail websites. So there are hundreds, thousands of retail websites. Let's talk about some financial website, banking application, banking websites, right? Or different kind of lots of websites, right? That you educational institutes related website, college related websites, right? So they're in numbers, they're in lakhs, right? So it means, let's say if I develop a website for a college or institute, or again, let's say for a bank, or let's say for an insurance company or somebody else, and there are thousands of insurance companies, right, who need a kind of website to be developed or some application to be developed. It means somewhere, whether it is insurance company A or insurance company B, they may have some kind of different requirement, but definitely there would be a lot of things in the common, right? There are a lot of things for insurance company A and insurance company 2. If I'm developing a website for or an application or software for insurance company A, and somebody else is developing a software for insurance company B, right? Then definitely there will be some changes in the requirement, but there will be a lot of common things as well. There will be common kind of scenarios as well. There will be common kind of problem statements as well, right? So now, so what has happened, right? So because software industry is now kind of matured enough, and we have a lot of people working here for decades and decades now, right? So there are people who thought through all these things. They thought through all these common use cases, common issues, or common requirements, right? Common problems that we have in developing the software, in coming out of some kind of design which can help us in developing a software and keep extending, keep managing code, so that the code is maintainable, and it is like more reliable, more robust, and a kind of right? So thinking all of these things, right? They came out a kind of some kind of generic design structure, some kind of generic class structure, some kind of generic design, right? And they said, okay, fine. See, let's say, take an example. I have a problem that my business requirement is something like that. I have lots of objects. Let's say I have created a class, and my business use case says that I should not be having more than object of this class at any given point of time. Okay. Now, let's say this if problem is given to person A, let's say to me, right? I'll start thinking how to make my class in such a way that anybody who wanted to create an object, they should not be able to create an object more than once. And if somebody is trying to create an object, they should be getting the same object what was already created. So there is some kind of thought process. Okay, then I have to think about, okay, fine. Let's say I have to create a class, then I have to do some kind of logic I have to keep there, so that if somebody is trying to create an object again and again and again and I think it should not be given an opportunity to create an object again and again, right? Then I'll come up with some kind of thought process, and I'll come up with some kind of logic, and then I'll implement the same the same solution, or sorry, same kind of problem is given to person B. Then again, what he has to do? He again has to think through it. Okay, now because this came to me, I solved. Again, the similar kind of thing will go to person B. He'll also think through, okay, now what I have to do, right? How I have to solve it. And then he'll start thinking out, and then he'll start. Same will go to person C, D, E, so many people, right? And then everybody will start thinking. So then what happened? So I have given you one example, right? That let's say this was one of the use cases. Let's say there is a separate, different kind of thing that different kind of use case. There's different kind of use case like my use case is something like this. I wanted to create some class. I wanted to add some properties, some method today. And this is my today's requirement. But I know that in future, I might need to add some more properties for more methods. Okay. But wherever I'm implementing this class, I do not want this, wherever I have implemented my client code, right? I do not want this to be changed again and again. Right? So now this problem was given to me. Okay, hey, this is my requirement for now. Okay, you have to create a software for this. You have to write a code for this. But then keep in mind that tomorrow my requirement will keep extending. I wanted to add new features to this class. I wanted to add new methods, new functionalities to this class. Okay, and at that time I don't want a lot of changes to have. So make sure that you keep a provision for all those things when you are developing a software for me, right? So then what I'll do, I'll start thinking how to do that, right? Then the similar kind of problem will be given to person B. So let's say I have solved it. Now same kind of problem is given to person B, C, D, and all, right? So what has happened is due to all these things, right? So there are a lot of common kind of problems are there, which which you would be seeing in a lot of software development projects, and people would be using it. So what people did is they come up with some kind of generic design pattern. Okay, some generic design, and they said, okay, look, if you have this kind of problem, maybe you can use this kind of solution. So now what happens? I have a problem. I have given a problem statement A, and I will tell, okay, fine, do one thing, use this design pattern A. Right now, if I say design pattern A, a person would be able to understand what I'm talking about. So I'm giving a solution, and now this solution I have not thought about. This is already been thought by somebody. They have designed it. They have told us, and then we are just using it. So now I'm not thinking how to implement. Okay, the problem statement is I have a class today, one class, and I have some properties, some methods. But my requirement is today, this is my limitation, this is my scope, but tomorrow it is going to get changed. We need to add some more and more functionalities to it. This is my requirement, right? So now what I have to, I'll say, okay, you have this kind of use case, do one thing, you use design pattern B. Here in this case, decorated design pattern, right? So for the other thing that I said, where I wanted to have a single object, at any given point of time, I'll say, go ahead and implement singleton design pattern, right? So in this case, what is happening is you don't have to reinvent the solution. You don't have to think about the solution, right? So this is what it says is a standard solution to a common class problem. So it's a solution given to you, but does it have a code? No, it will not have a code. It will have a kind of structure, class structure. They will say, or the design pattern will say, okay, fine, this, you have this problem that you don't want to have more than one object of a given class at any given point of time. Do one thing, you implement your class in this way. You keep your class like this, you have some kind of method created like this, you have, if required some interface, you do this, you do this kind of implementation, and you'll be able to achieve it easily, right? So then, okay, fine, so now it is defined. So I'll just say use this a singleton design pattern, you will get it. So anybody else who knows about the singleton design pattern, they will get it. I don't have to explain a lot, right? So what it says is it's a kind of standard solution to a common classic problem. Okay, now what it says is this is a technique for making code more flexible by making it meet certain criteria, right? So what is the so one is this, it's a kind of standard solution. Second thing is, actually when somebody has given you these design patterns, they thought through a lot of things. Okay, they thought through, if you implement this in this way, is your code maintainable? Is your code flexible enough that tomorrow if you wanted to make some changes, you can still make a change, but then your client doesn't need to suffer a lot. Your client code or your client application, whoever is using your these classes, right, they don't have to make a lot of changes, right? So so these things are kept in the mind when we came up with a design pattern, right? So design pattern is a kind of standard solution. Then it also helps you, if you follow this design pattern, your code is more maintainable. It is more flexible for getting any kind of extension. Okay, it also follows some kind of solid design principles also. We'll talk about the solid design principle, that's a different topic. But then I just wanted to tell you, like, no, when the design patterns were formatted, right, when the design patterns were created, right, it is done based on lots of use cases, based on lots of experience, lots of, right, and lots of thought process was given, right? So now if you know all these design patterns and if you get any kind of similar kind of use case, then you don't actually need to think of how to solve it. You have a solution already available, you just go and pick it. Okay, this is my use case. Okay, for this use case I can go and pick this design pattern. It will, I know I have the ready-made solution, right? So now what it says is a design pattern is an implementation or a design structure that achieves a particular purpose. So now, one solution, let's say, can one solution fit for all the issues? No, right? So it means one particular design pattern can handle a particular kind of use case. Let's say I have a use case that I wanted to keep extending. So there will be a design pattern. There is a design pattern. So this design pattern, if you implement, this will mainly focus on how to structure your class, how to create your class in such a way that you can keep extending it without making a lot of changes to your existing code, without making a lot of changes to your existing solutions, so that your client doesn't need to do a retesting of the existing code and all, right? He has to do the testing for only the new extended feature, not for the existing one, right? So now it says it is a shorthand for describing certain aspects of programming organization. So aspects of program organization, right? So basically, as I said, if I know people around me, they also are aware of the design pattern, right? I can directly say, okay, this is a solution. You go ahead and implement singleton, or you go ahead and implement prototype design pattern, or you go ahead and implement bridge design pattern, or decorator, or any other design pattern, right? So if the people understand, they will also understand in very easy way, right? So it's a kind of shorthand, right? I'll just use this. It's an easy way of communication also, right? And then it makes the problem very easy. Where the some time ago, when you're thinking about all these use cases and your requirement, you might be thinking, oh my God, it's like too much of requirement. But then when you know the design pattern and you know how to solve it, right? How you can create your classes, how you can have your structure of the classes, how you can maintain, how you can have multiple classes and make some kind of relations and all, right? And it will make your life easier. All right. Next moment you are like relieved. Okay, fine. I'll go ahead and implement this, and this is how I am going to structure my class. These many classes I'll create, right? So this is what it's going to help you in that way. Then what it talks about the connections among program components. So it also talks, so mainly design pattern talks about what? It mainly talks about your classes. It talks about your objects. It mainly talks about multiple classes and how these classes can be related to each other. Okay, so relationship between the classes, how we can make it more useful, how we can relate all these classes, how we can make a communication between one class to other class, right? So this mainly design pattern talks about the classes, objects, properties, methods, interfaces, encapsulation, and all those stuff. Okay, so there is one more question that comes up, like, what is design pattern and what is architecture pattern, right? How it is different, or what is the difference, right? So mainly architecture pattern, we'll talk about in a separate session maybe, but for one liner, I'm just telling you here is architecture pattern is like one level up above to the design pattern. So design pattern, we talk about the class, objects, and all those things. And in architecture pattern, we talk about the components, right? Like my presentation layer, my model layer, mm, my database, my business logic, my business layer, and all those stuff. My physical layer, we talk about the physical layer, we talk about the logical layer, and how these all different layers will be connected. Or let's say I have my some broker, some kind of message broker or something that I'm using. So how many other different components, different application would talk to each other and all, right? So those kind of things we talk about in architecture pattern. But in design pattern, we talk about the implementation part, how to implement the class, how to create the classes, how to make the classes talking to each other, how we can instantiate a class, how we can add new feature to the class, right? How the classes can communicate and all, right? How we can solve some threading, how we can solve some asynchronous programming and all those stuff, right? So those things we talk about in the design. So now, what is, when we talk about the design pattern, what is given to you? So basically, if you go through the design pattern, normally what you'll get is some kind of diagram, class diagrams, right? So basically, they will tell, okay, fine, this is a singleton design pattern, and this is your class diagram. This is how you should create it. So it's not something that it actually talks about your use case. It doesn't talk about your use case. It talks about a generic problem statement. Okay, so when we are talking about the generic problem statement, it will give you a generic class diagram and all. Okay, fine, you wanted to implement factory design pattern for such and such use case, you go ahead and do like this. You create your classes like this, you implement your classes like this, you have an interface here, you have multiple classes like here, you create an object like this, and all this, right? So basically, when we talk about the design pattern, it gives you some kind of diagram, object diagrams, right? So this, and then you have to understand that, and then you implement based on your use case. You see how you can implement, a particular design pattern for in your use case. Now, one of the most important thing, it's language neutral. It doesn't have, it is not specific to any language like C# or Java or whatever, right? So any kind of language you're using, you can use design pattern, right? Now, next, one of the very important thing, what it is not, right? We understood what is design pattern. Now we'll try to understand what it is not. So actually, I've already discussed, right? It's not some kind of ready-made solution. It's not a ready-made code. Okay, it's not a code. So it's not a code that you can copy and paste and you can use. No, it's not a code. Okay, it's not a code written in any language or anywhere and then you can copy paste. No, it's not a ready-made code. It's a high level or generic diagram or some kind of class diagram or something, right? It's not a code, and but this diagram you can implement in any kind of language, whether it is C#, Java, any other object-oriented programming languages. Right? Second thing, it is not a feature of any programming language. Design pattern is not a feature of any programming language, whether it is C# or Java, whatever. It is not something like, no, that's Microsoft or Oracle or some microsystem has given you some kind of function or method already created, and this is, they say, okay, this is a design pattern. No, there is no such method created, right? It's just a concept. It's a kind of diagrams, classes, objects, and how to implement this, right? That's it. Now, classification. So what happens? Design patterns basically broadly categorized in 3 categories, and this category is defined in GOF, Gang of Code book. Okay, so basically it doesn't mean that whatever is written in GOF, that is the only that is the only thing that comes under the design pattern. No. We can say that GOF design patterns. We can say it's a kind of fundamentals of the design patterns, or you can say kind of it's a basics of the design patterns, or you can say that it's a foundation of the design pattern that you can use for creating other design patterns, right? For that you can use for your own solution and all. So there are a lot of other design patterns also, but then yeah, somewhere you can utilize all these design patterns as well. Okay. So if you go with the GOF classification, right, this is one of the very important question for the interview as well. So please take a note of it. So what are the different kind of design patterns, or what are the different kind of classification, or what are the different types of design patterns we have, right? So mainly we have three design patterns: it's creational, structural, and behavior. And this division or the classification is done based on the GOF book or GOF patterns. Okay, but apart from that, there are other design patterns also. As for example, I have written here like this repository design pattern, and there are a lot of others. In GOF, right, they have actually given you altogether 23 design patterns, and those 23 are classified into these three broad categories: creational pattern, structural pattern, and behavior pattern. So we'll just touch upon on these three classifications at a very high level. And I have already created a lot of videos for you where you can go through these design patterns, and you can try, learn, and understand about these design patterns, right? So here my focus is only to talk about what are these different types, what are the different kind of design patterns we have as a part of the GOF Django 4, right? And the implementation part and all, I have created a lot of other videos. You can go through those videos and you can understand and learn about all these design patterns. But where I am giving the names only here. But if you wanted to learn those design patterns, I request you all to go through the design pattern videos that I have already uploaded, and you can learn all of them one by one. So first of all, the creational design pattern. So creational design pattern actually it talks about the object instantiation. How you wanted to create an object. Now you would be thinking, why do we need to come up with a design pattern just for creating an object? Yes, there are a lot of use cases where creating an object is also a focus area, and we need to think through how to create an object, right? To more effectively, so that if we create new classes or in future and all, right, we don't have to make a lot of changes in our client. Okay, so if we go with the creational design pattern, there are mainly 5 design patterns: singleton, factory, abstract factory, builder, and prototype. And as I said, all these design patterns I have already discussed in my other videos, right? And then you can go ahead and watch those videos and try to understand these design patterns. And if you have any question during when you are going through these videos about any of these design patterns, feel free to add your comment in the comment section, and I'll be there to reply all your questions. Yeah. Now, if we go to next, a structural design pattern. So basically, in this design pattern, we have categorized those design patterns which normally focuses on adding new features to your classes. Okay, so how can we add, keep adding new features to your classes, and then it doesn't break your client code, or there are very less chances of making the code changes to your client, right? So and then if you go into the structural design pattern, we will mainly we'll see adapter, decorator, prism, composite, facade, flyweight, and proxy. So these are the different design pattern which helps you in increasing the size of your classes. Or when I say increasing the size, it doesn't mean the line of the code, but adding new features. It will make your classes more and more complex. It will make your classes more and more bigger and bigger, right? And you can do it in a like kind of gradual way. Okay, so today I have this, I'm fine with this. Tomorrow I wanted to add more, we can still add more, but I don't have to test on my existing code, and my client doesn't need to go ahead and retest each functionality of the existing things as well. So he can mainly concentrate on the newly added functionalities, right? So this is all about the structure. And again, I have been still creating the videos, and also as and when you see the videos are created for all these design pattern, you can go ahead and watch those videos. And if you really wanted to get some kind of notifications. So please make sure that you subscribe to my channel so that you will get a notification automatically as and when these videos are uploaded. Now, next is the behavioral design patterns. So these are the design patterns which normally talks about communication between more than one objects, right? So let's say I have object 1, object 2, and then we have to do some kind of communication, right? We need to make sure that these two objects are talking to each other. These two classes are talking to each other, right? So these kinds of problems, these kinds of use cases are different use cases, right? These kind of use cases are solved by using behavioral design. And then in behavioral design pattern, we have many number of design pattern, and this goes with observer, command, strategy, chain of responsibility, interpreter, iterator, mediator, memento, state, template, and visitor. And again, these are all, I would be making the videos for all of these design pattern one by one. And as and when I upload the video, you'll get a notification if you have subscribed to my YouTube channel. So, and anytime if you have any question on any of the design pattern, once you see these design patterns, the videos are getting loaded, and if you see, go through it, and if you have any question, please add your comment in the YouTube videos, and then so that I would be there to reply back to all your questions. Yeah. So that's the most important thing. So if you go through these videos, and if you have any concern, questions, clarification required, or if you have some use case scenarios, and if you wanted to understand more on that, right, or if there is something which is not clear to you, feel free to ask questions, feel free to add your comment, and I'll be answering all your questions. Now, talk about some of the most used design patterns. So I have categorized the mostly used top 5 design patterns. Okay, so top 5. So there are 23, and there are some other design patterns also, but there are some common scenarios that you would be going through in lots of software whenever you're developing software. Some of the use cases you'll definitely be finding, and then you can implement these design patterns, right? So this I have taken a note of some top mostly used design patterns, and when I say it is mostly used, this is also mostly used or mostly asked interview questions. Okay, so please focus on all these design pattern, because it is very important for your interview purposes as well, because it is, as I said, it is used most, so it is being asked also most. Okay, so make sure that whenever you go for interview or anything, you do a kind of freshen up, and then you just do a kind of revision of all these design patterns before you go for any kind of interviews. So here the mostly used design patterns, if you go in the creational, we have singleton and factory, and a structural decorator, and in behavioral command and observer. It doesn't mean that you have to think about only 5. There are the design patterns also which are also important, like base, like adapter, proxy, state. Like there are other design patterns also, they are equally important, but as I said, these are something like which is mostly used. Okay, these are mostly used design patterns, and people normally ask questions on these design patterns, right? Now, most important question: how to pick up a design pattern? Right. So let's say you have been given you wanted to work on a software, you wanted to develop a software and from scratch, and then you have been given your all these use cases and everything. Now you have to pick up, you have to think of how to implement the design pattern, how to pick up the design pattern, which design pattern you wanted to pick up. So first and foremost, if you wanted to pick up any design pattern, first thing is you must be knowing about what are the design patterns available, right? For that, you need to learn the design patterns first. So focus on learning all these design patterns first. Once you know what are the things available, what all things are available, right? And then once you know what all things are there, right? Then you also will be knowing what is the purposes of all these design patterns, right? So first thing, you must be knowing all this. Then only you can make any decision. If you know 5 things, then only you will have a problem of which one you have to pick, right? If you don't know any, then you don't have any problem. Then what you will do? You will start thinking through the solution, and you will end up some kind of design, some kind of solution which may or may not work, which may break something else, or we may, it's not something it will break it, you may come up with some better idea also, there's no problem. But then what is going to happen, you are going to put a lot of time and effort in coming out some kind of new design, right? But if you know about the design pattern, and if you know your use cases, you can pick and choose. Okay, my use case is matching to this, you can pick one. So first thing is, you need to know all the design. Second thing is, if you know all these design patterns, it means you also know what are the different use cases that each design patterns can be used for. And then you think about your use cases and scan through all these design patterns, and then think what is the most suitable design pattern for you, right? Third thing, there are design patterns, right? Let's say for creation, I have 5, right? Then behavior, I also have many. Structure also I have many, right? Then there would be some kind of relationship, some kind of right, some kind of creation. I have singleton, also I have factory, I have abstract factory, I have prototype, I have builders, many, right? Similarly, I have a behavior. Similarly, I have a structure, right? So now definitely there is some kind of relationship also, right? Then you have to think about, okay, design pattern 1, design pattern 2, these are interrelated, what kind of relationship they have, right? And then you have to think of, okay, my use case is this, which design pattern fits to my solution, right? Fits to my problem, right? So then you have to think about the relationship between design pattern, right? Then there are other cases where you might be having a kind of mix of design pattern, right? It's not that your entire software will be built up based on only one design pattern. It is not possible. It's not going to happen anytime, right? So what is going to happen? So you have to use multiple design patterns for a particular software development, for a particular application when you're developing it, right? So it means until unless you know all of them, right, you might end up with wrong selection, wrong choice. So first is, you must know all. Second thing, you must be knowing use cases. You must be knowing, third thing, you must be knowing the relationship between these design patterns, right? Then also, when you are thinking about the design pattern all right. So as I said, there are some, so you also need to think about, you have to foresee a kind of the reasons why you might need to read, let's say, when you're selecting a design pattern, right? When you are coming up with a kind of solution, you wanted to give a solution, right? So basically, you do not have to concentrate only on today's problem statement, whatever has been given to you. You also need to foresee what are the different reasons, what are the different things that might come in future, and you might need to redesign your solution, right? So you need to foresee all those things, and then based on that, you need to pick up a design pattern. So you also need to think, okay, today is my scope, this is my limit, this is my scope for today. What are the different things that might come tomorrow that may require me to again redesign my software, right? And if you are able to think all these things, right, then you will be coming up with a better design pattern for you, which is most suitable to you, right? And you will not be doing any mistake, and even it will be kind of future ready software, right? So I am not telling something that no, you can think of something which will work for 20 years. There is nothing which will work for 20 years. If you think about the computers or the desktop that we are using today, it was not the same way 20 years ago. It was like almost, if you compare 20 years old computer to today's computer, you would be thinking, my God, like how people would how people worked on those computers, like it was super slow if you compare with today, but 20 years ago that was a big thing. So again, today you have something, definitely whatever the things you are going to do, it won't work for 20 years, that is for sure, but you at least have to think for 5 to 10 years. That's the normal age of any kind of software. So, and within these 5-10 years also, you will go with multiple evaluation, lots of changes will happen to your business requirements, right? Business is not constant, requirements are not constant, it keeps changing due to lot many factors, right? So definitely you might not be able to think about everything, but at least you need to put maximum effort in making sure that you know what all things that might come, right? Talk to your business analyst, talk to your product owner, understand, right, before you are actually coming up any kind of solution, right? So you have to foresee. If you're not able to do that, your solution you have to rewrite the things one more time within 3 years or 4 years of time, right? So, and this is not a good thing, right? This is going to be very expensive and very costly, right? So you have to do that thing as well when you are developing a new skill, right? And then, or when you are picking up, or when you're thinking about what kind of design pattern you want to use, right? So now these are all the theory part, like, what is design pattern, what it is not, uh, what design pattern you should be picking up, what you should be thinking when you wanted to pick up any design pattern. And before you can think of what design pattern you wanted to use, most fundamental thing is you must be knowing about all these design patterns. If you don't know, you have no option of thinking itself. So first thing is you must be knowing. Then only you can think. You have an option of thinking. If you don't know, then you are not thinking. Then you are only thinking about solving the problem what you have, and you may or may not be ending up with a better solution, right? Which is already been defined, and you could have used it, right? Now, as we discussed in the beginning of the session, that design pattern, when we talk about the design pattern, what it is, actually, it is nothing but some kind of class diagrams, right? And that can be represented in UML or any kind of diagrams, right? So as we have discussed so many other design patterns, right? So, and whenever we discuss about any design pattern, normally I go through all these class diagram. So for them, so if you see, like, some design pattern, I have taken here a builder design pattern example. So forget about the name and all. So normally any design pattern, if you go, you'll see this kind of diagrams, which will talk about classes, interfaces, the relationship, inheritance, encapsulation, all those, right? So this is how it will come, like, right? So design pattern, as I said, it's not a kind of written code that you can go ahead and copy paste. So you'll get this kind of class diagrams and all, right? And then you have to think about, okay, and then there'll be some kind of small use cases given, and then you have to think about those, understand it very minutely, so that you can relate all these design patterns with your use case, and then you can be able to, you can pick up better design patterns for you. And then I have given you one use case here. Same, this is a kind of email diagram, and then there is some use case that I have done in the builder design pattern, and you can see this video. It's the same kind of, it's the same PPT that I have kept it. So you can go through this video in my builder design pattern session. So if you wanted to understand what it is, so basically it is, I have taken it from my builder design pattern session. So you can go through that video to understand what is the builder design pattern. Right. So I think we have talked about many number of things today, and hope it will help you to face any kind of interview, and any kind of question that comes up with the, with respect to design pattern. Like basically some kind of initial question, like, what is design pattern, what do you think about the design pattern, when you should be implementing the design pattern, when you should not be implementing design pattern. So when you should not be implementing design pattern, I think we have not talked about. So it's basically, so first thing, do we need to implement this design pattern all the time? It's a very straight answer, no. Okay, design pattern doesn't need to be implemented every time. Okay, it actually, when we implement a design pattern, it actually adds some kind of complexities as well, right? So you also need to think through, okay, fine, if this is my use case, can I make it even like, if you don't use a design pattern, your code could be a little bit smaller, right? But then yes, definitely it will not have some kind of benefit like extensions and all. So if you think that you don't have a lot of extensions, it's a small application, small thing, a small tool that you're developing, then definitely you can leave implementing the design patterns and all. But yes, if you're working on for a big application with lot of changes that you are expecting, you wanted to extend it with more and more features in the in future, right? So definitely we're thinking of the design pattern, right? So we have talked about, like, when to use design pattern, when not to use design pattern, what is design pattern, what are the different types of design patterns, what are the different things that you should be thinking of before you pick and choose any design pattern, right? So that is all for now for today's session, and in the next session we'll be talking about some other design pattern, the implementation and understanding of that, and hope it will help you all. And if it makes any kind of sense, and then please comment, please add your comment. And if you have any kind of clarification, and if you have any kind of questions, comments, suggestions, please add your comment in the comment box. And if you think that if it is going to help some other your other batchmates or colleagues or classmates, right? So please share this video with all of them. uh, do not hesitate in sharing it. Share with everybody so that everybody can get the help of what help, some kind of help, and they can understand, and they can maybe some get some new job or whatever, right? So thanks a lot for watching this video, and we'll be again meeting in some other next some other video where we'll be talking about some other topics and all. Thanks a lot for watching this video, and have a great day.